Welcome back. So in the previous concepts, we have studied different properties of colloids, different preparation methods of colloids. So what I need to mention is, I was happy knowing that most of the students responded for the video and they got their doubts clarified and they had contacted. And let me mention few of the doubts which even others may have but might not have opened up. So the first question a student who had asked was related to micromolecular colloids and associated colloids. The student had a doubt that what is it about micromolecular colloid and associated colloids. So let me tell you, in micromolecular colloids, the atoms, which are the smaller particles, they come together and then they form colloidal range of particles. Are you getting the point? Whereas in associated colloids, you can see that there is a condition of Kraft's temperature and critical micelle concentration. Under that or above that particular condition, you see formation of associated colloids or micelle formation takes place. Another one was related to Tyndall effect. In Tyndall effect, the question was, yes, you said that most of the colloids satisfy the conditions. I mean, most of the colloids will show Tyndall effect. Then why are those conditions? The two conditions were of refractive indices and other one was of particles. See, yes, almost all the colloids shows Tyndall effect. It's that the conditions are satisfied. The conditions are, you imagine, if the particle is very small that the wavelength of light cannot strike it, then how can it scatter the light? Yes, so we say the particle size must be larger, the diameter must be larger compared to the wavelength of light that is used. That is one. The other one is of refractive indices. Alright. The next question about color of the colloidal solutions. Color of the colloidal solution, I had mentioned that gold sol will be red in color and then it turns as the particle size increases, it becomes purple and finally it becomes golden. So finally it becomes golden in the sense after purple it passes through blue color also. Blue color also will be seen. That is also right. Okay. So these were the questions which I do remember now. And now let us move on to the next property. Okay, one more question was related to preferential adsorption. The question was, what actually is preferential adsorption? We are not getting it. The thing is, now a precipitate is formed. I had given example of potassium iodide and silver nitrate. Now AgI, silver iodide is the precipitate formed. It has a tendency to attract ions from the solution. So it can attract a positive ion or a negative ion. See, it can prefer. It can choose. So we call it as preferential adsorption. It gets the charge adsorbed on it. That is why we call it as preferential adsorption. Okay. Next method or property is electrophoresis. This is a continuation of colloids. Electrophoresis. Now what is this electrophoresis? A rough schematic diagram of the process apparatus I have drawn. Electrophoresis is an experiment which tells or with which we can know whether the colloidal particles or colloidal solution is positively charged or negatively charged. So what do you get to know? We get to know whether the solution is positively charged or negatively charged. The colloidal solutions. About the colloidal solution we will get to know. That is by electrophoresis experiment. Now let me explain you the setup of this. This apparatus contains U-shaped tube where the two electrodes are taken, usually platinum electrodes are taken, and they are externally connected to the circuit. One is a negatively charged electrode and the other one is positively charged electrode, anode and cathode. Now this is a reservoir. Reservoir is through which you can add the colloidal solution. And you can see these two lines, isn't it? What usually will be done is, colloidal solution will be filled in this, and this will be taken as initial level, and they will make a mark. Here it is said to be final level, or say initial level itself. Now what happens when the electric current is passed or electric field is applied? Then if suppose the colloidal particles are, you know that it can be positively charged or negatively charged. If it is a negatively charged particle, it moves towards which direction? If it is a negatively charged particle, they move towards the positively charged electrode, and they gets deposited on the electrode if it is negatively charged. If suppose the particles are positively charged, what happens? If they are positively charged, then the particles move in which direction? They move towards the anode and gets deposited. Now how do you know whether it is a positively charged one or negatively charged one? Same, here we have filled with water, isn't it? A layer of water. If the particles are moving in the other direction, then here the level decreases. So what do you say? The particles are positively charged, so they have moved towards negatively charged electrode. That is how we get to know from this particular experiment. Here we are speaking about the movement of dispersed phase. Okay, here we are speaking movement of dispersed phase particles. If the movement of dispersion medium itself takes place, say in simpler words, solvent takes place, dispersion medium, then we call it as electroosmosis. The movement of dispersion medium under the influence of electric field is called as electroosmosis. So hope it is clear of what is electrophoresis. Now next let's move on to the next very important property of colloids, called as coagulation. Coagulation is also called as flocculation, or it is also called as precipitation. Coagulation is also called as flocculation or precipitation. What happens here? See, in coagulation or precipitation, you have an idea. Precipitate means something which settles down. In coagulation, the method or the process of conversion or converting colloidal particles, or simply say process of converting colloids into precipitate. Is called coagulation, or in another word you can say process of conversion of colloids into precipitate, or the process of settling of colloidal particles, or how can you define? The process of settling of colloidal particles or colloids is called as coagulation or flocculation or precipitation. Is it clear? Now let us see which are the different methods how coagulation can take place, or how coagulation can be carried out. Please note this. The definition of coagulation is again important. Okay, so we know colloids can be converted into precipitate. Yes? Which methods it can be converted? Methods of coagulation, or how to coagulate. The first method can be the previous one which you have studied. Very easy again. It's electrophoresis. One is electrophoresis. Let me tell you how. The other one is by mixing oppositely charged souls Oppositely charged sols. The other one is by boiling. The other method is boiling. One more is by persistent dialysis, continuous dialysis. Or the other method, very important method, is by the addition of electrolytes. So let me explain how these can be carried out. Electrophoresis, just now you have studied. Electrophoresis is where in the apparatus electric field is applied. When electric field is applied, if it is positively charged substance, it moves toward the opposite charge. There what happens? Oppositely charged electrode, it gets deposited. So what happens in the solution? In the solution, now all positive charge gets deposited on the negatively charged electrode, for example. Then what happens? The solution will contain only negative charges. Am I right? Because they were balanced. Say for example, a small amount of electrolyte is required for balancing, right? They gradually settle down. They lose their charge. The solution will lose their charge and it undergoes coagulation. So by electrophoresis. The other one is by mixing oppositely charged sols. By mixing oppositely charged sol, in the sense you have studied different types of sols. You have studied positively charged sol, negatively charged sol. So if we mix these, one positively charged sol we mix with negatively charged one. So what happens? Coagulation takes place. They get neutralized. Positive charge balances negative charge and they neutralize. Finally, they precipitate or coagulate. That is the second method. The third method is boiling. So we know the stability of these sols are because the particles are continuously moving in zigzag motion, Brownian motion. What happens if you start boiling? If you start boiling, the motion of particle will increase, kinetic energy increases more. After that, after some time, you see that coagulation, it results in coagulation, it precipitates. Persistent dialysis. Persistent dialysis is where, dialysis you know, isn't it? Again, in a membrane, the colloidal solution is taken and it is continuously washed. What happens? Excess electrolytes or any impurities are present will be washed away. If you continuously do it, persistence means continuously, if you keep on doing it, the electrolytes which is required for the stability also will be removed. If the electrolytes required for the stability is also removed, then coagulation takes place. It loses its stability and hence it precipitates. Addition of electrolytes. This again you know. Small amount of electrolyte is required for stability. But if suppose you add extra electrolytes, what happens? Finally the colloidal solution loses its stability and hence they precipitate. So these are the methods of coagulation. Now since we are studying about coagulation, here comes a very, very important rule called as Hardy-Skulls rule. Hardy-Skulls rule. So the ion or any species which causes coagulation is called as coagulating ion. Okay, what is it called? Coagulating ion, or you can also call it as flocculating ion. What is coagulating ion or flocculating ion? The ion that causes precipitation or coagulation. Now Hardy-Skulls rule states that greater the valency of flocculating ion, or greater the valency of coagulating ion, greater is its ability to cause precipitation. Are you getting the point? More the valency, more will be its ability to cause precipitation. Let me give you an example. Before that, please do note this Hardy-Skulls rule. It states that greater the valency of flocculating ion greater is its ability to cause precipitation or coagulation. Now let me give you some example along with which it will be clear to you of what this rule states. See, if suppose you have a negatively charged soul, you have a negatively charged soul and you want to coagulate it. You have a negatively charged soul and you want to coagulate it. You have the positively charged ions as Al3 plus, Ba2 plus, Na plus. Okay, so let us see the order of power of flocculating ion. This is for which one we are studying? For negatively charged souls. In this case, for negatively charged souls, let us see, we have these ions Al3 plus, Ba2 plus and Na plus. Which has more valency? You know what is valency, isn't it? Yep. So now here, which has more valency? 3 plus, 2 plus or 1 plus? 3 plus. The valency is greater in aluminium, Al3 plus. So what should be done? Which one will have more flocculating power? Greater the valency of flocculating ion, greater is its ability to cause precipitation. So Al3 plus can cause more precipitation. So this will be showing more power compared to the next one. Now comparing Ba2 plus and Na plus, Ba2 plus will show more power of flocculation or coagulation. Is it clear now? For a negatively charged soul, aluminium 3 plus can show more flocculating power compared to the other two since its valency is greater. Similarly, let us see if in case of positively charged soul, then the flocculating power order will be, say we have Fe, Cn6, 4 minus, PO4 3 minus, SO4 2 minus, Cl minus. Which one has more valency? Here 4 minus, here 3 minus, 2 minus, 1 minus. So this will have more tendency to cause precipitation in case of positively charged soul, then this and then this one. This is what Hardy-Sculls rule states. Hope it's clear now. Do note it. Now next we shall move towards coagulation of lyophilic souls. Coagulation of lyophilic souls. So coagulation of lyophilic souls, coagulation, you know what it is. It's nothing but precipitation. Lyophilic, water loving. Yes. So let us see. Now coagulation means it's nothing but you are reducing its stability. Yes, you are trying to decrease the stability of that particular soul. First let us see, if you have to decrease the stability, then you should know the reasons for the stability, right? One is charge. The other one is solvation. These two are actually its strong points where it increases the stability of colloids. It's maintaining stability of colloids. So we want to cause coagulation. So what should we do? We have to cancel this effect, or we have to decrease these effects there. How? So remember, the reasons for the stability of lyophilic souls are charge and solvation. Solvation, you know, right? To what extent it can be miscible with the given solvent. It can be mixed with the solvent evenly. How can you decrease the charge? We can bring about coagulation by adding electrolytes. Then what happens? Charges will be adsorbed. Finally, coagulation takes place. If the electrolyte concentration increases, then coagulation takes place. So in case of solvation, say for example, lyophilic means it loves water. So with water it has formed a colloidal solution. But we want to decrease its stability. So what we will do, we'll add a favorite one, alcohol or acetone. Alcohol or acetone, they are volatile. They tend to evaporate. So they evaporate, they loosen the stability of the colloids also. Water vapor can be evaporated, hence the stability of colloidal solution will be lost. So because of which coagulation of lyophilic salts can be carried out. Are you getting the point? Okay. Next we'll see protection of colloids. That too, protection of colloids. Which kind of colloids can protect which another kind of colloids? We have two types of colloids, lyophilic and lyophobic. So you know, lyophobic means which hates water, isn't it? It hates water. It doesn't want to come in contact with water, so it always tries to remain away from water. The other one is lyophilic colloids. Now what happens? These lyophobic colloids will be protected by or can be protected by lyophilic colloids. So these lyophilic colloids, no, they form a protection layer around it. So it will be like, okay, fine, you however you don't like water, isn't it? But I do like water, so I will protect you from water. So it forms a layer or a cover over that lyophobic colloid, because of which this doesn't come in contact with water and this protects. Such colloids which protects the other colloids are called as, here this one is called as protective colloid. So which type of colloids can act as protective colloids? Lyophilic colloids can act as protective colloids. Is that clear now? All right. We will move to the next part where it's about emulsions. So we have studied about emulsions, isn't it? Different types of sols, solid sol, aerosol, emulsions, gel, all that we have studied. Now we will study some important points related to emulsions. So remember, emulsion is where liquid itself is the dispersed phase, liquid itself is a dispersion medium also. So here liquid, these are emulsions are liquid colloidal systems. That means liquid is dispersed in liquid again. That is what it means. So here we have two types of colloids, two types of emulsions. Which are the two types of emulsions? One is oil in water type emulsions. We denote it this way, oil in water type emulsions. And the other one is, second one is water in oil type emulsions. Water in oil type emulsions. We denote it this way. Now let me give you some examples for this. Oil in water type of emulsions. Examples are milk, vanishing cream, etc. And in case of water in oil type of emulsions, examples are cream, butter. These are examples for water in oil type of emulsions. So now what we need to know is these kind of emulsions, where oil and water type of emulsions are usually unstable. You know, after long time, what happens to milk? Curdling of milk takes place. Yes, milk gets converted into curd. So that means these are unstable. Which type of emulsions are unstable? Oil in water type of emulsions are unstable. So you cannot store them for long time. Now what can be done to store it for long time or to prevent the instability of these particular colloids? We can add some agents, stabilizing agents. So what are those stabilizing agents called? The stabilizing agents which we add are also called as emulsifying agents. You might have seen in ice creams, if you just check out, then you can see in behind it will be written as emulsifying agents. That means it prevents from it getting spoiled. It prevents the instability of these kind of emulsions. So that is about oil in water type of emulsions. Okay, so here we were speaking about emulsifying agents. I have told you the stabilizing agents which can prevent the instability of colloids. That means which can avoid the coagulation of colloids is called as emulsifying agent. So here in oil in water type of colloids, the stabilizing agents can be synthetic soaps or gums, etc. These can be the stabilizing agents. Whereas in water and oil type, long fatty acids can be used as stabilizing agents. This is what we need to know about emulsions. So next I have noted some colloids around us. The colloids which we see around us. So let us have some idea about it. We will study about it in briefly we will know about it. So colloids around us, one is blue color of the sky. We have seen blue coloration of the sky. How does it happen? So you know, in the atmosphere, the colloidal particles are dispersed. It can be smoke, dust or any other particles which can scatter the blue wavelength of the light, and that is why sky seems to be blue in color. Okay, next, fog, mist, cloud, rain. Fog or say mist, you know, in the gas, in the air, the water vapors are dispersed in different size particles. They are colloidal range of particles they are which are dispersed. And when do you say rain comes, or how do you explain the formation of rain? It is nothing but the clouds condense and then it gets converted in the form of rain, and so we can see the rainfall where the colloidal particle undergoes coagulation, where the size grows heavier and heavier, and finally it starts precipitating. When it starts precipitating, the size is very heavy now, and so it falls down in the form of rain. You might have seen artificial spraying of clouds and all those. No, it all follows the same thing, where the electrolyte will be sprayed there. Artificial rain, electrolytes will be sprayed so as to decrease the stability, and hence it condenses and forms rain. The next one is food articles. You have seen jellies or say butter, ice cream, milk. All these food articles, most of them are colloidal in nature. Say blood. Blood is again a colloidal albuminoid solution. It's a colloidal albuminoid solution. So what happens if suppose you have a wound? Then what do? You apply some medicine, isn't it? When you apply medicine, what happens? The blood gets clotted. The clotting of blood is nothing but coagulation that is taking place. Again, what does it mean? Blood is a colloidal solution. Soil. You have seen fertile soil. There, the fertile soil is prevented or protected by humus. Humus acts as a protective colloid there. Humus is nothing but dead and decaying matter of plants. They form a protective layer for the fertile soil. That is what we can see in the environment. Then delta formation. This is a common thing which you might have noticed. Say, the place where ocean or sea, the place where the rivers come and meet, this river meets ocean or sea, you might have seen a region called as delta, where the clay particles seem to settle down. You might have observed this. So what happens is, river is actually a colloidal solution of clay. Alright, so the sea will have sodium chloride or many other electrolytes present in it. What happens? Now this is a colloidal solution. It comes in contact with excess of electrolytes. Then here the charges are lost, and hence the clay particle stability is lost, clay particles settle down, and the region called as delta is formed. So river delta formation is again a type of colloidal behavior which we see around us. Now at the end we'll see some useful colloids or the importance of colloids. The importance of colloids, the first one which comes to our mind is precipitation of smoke. Importance of colloids. First one is precipitation of smoke, or you can say electrical precipitation of smoke. This follows some principle related to colloids. Here what happens, now from the industries we have a major problem of air pollution, right? So what happens, from the industries the smoke or the harmful gases will be let into the atmosphere, which leads to pollution. So what can be done is, before the chimneys from the industry, say from the industry the chimneys let out the smoke, right? Before passing out, it is passed through a chamber. Say it's called as cotral precipitator, where some metal electrode is used and a high voltage is applied. Okay, there will be inlet from the chimney, there will be inlet to this particular precipitator. Here it is charged to about 30,000 volts. You can just imagine, a very high voltage is applied, and now what happens, the smoke or dust or the substance carbon particles which are carried out along with the gases are passed in. When it comes in contact with this electrode, it gets discharged and the carbon particles settle down, and the gas that is free from the smoke or carbon particles will be let out. Again, this follows colloidal principle. The next one, we see purification of water. Purification of water is again very important. Drinking water, where if suppose water contains suspended particles, say it contains clay particles or dust particles suspended in it, then it is treated with alum. Alum is a salt of aluminium. When water is treated with aluminium salt, that is alum, the suspended particles settle down, coagulates and settle down. That is again purification of drinking water. Next, in medicinal fields, we can see the use of colloids. Most of the medicines are colloidal in nature. Say for example, eye lotion you use. It's a silver sole called as argyrol, which is used in eye lotion. It is used in eye lotion. And there is a disease called as Kala Azar. It's a common name, Kala Azar, which is also called as black fever. So for the treatment of this Kala Azar, the colloidal solution that is used is colloidal antimony. Colloidal antimony is used for the treatment of Kala Azar. Kala Azar is where you can see inflammation in liver or spleen. Or say in the stomach disorders, say gastritis, for the gastritis problem, the syrups which are prescribed, you might have seen, it's milk of magnesia. Milk of magnesia that will be used for the treatment of stomach disorders. Now the question is, why only colloids? Why colloids are used in medicinal fields? It's because they can be easily assimilated in the body. They can provide more surface area. So that's about medicines. And next, speaking about tanning. You might have heard of tanning. If you use leather goods, you can have a good idea of it. Tanning is where, leather in the sense it is manufactured using animal hides, animal skin. Animal hides we call them as hide. Animal hides are positive in nature. They are actually colloidal in nature. Now this animal hides are treated with a solution called as tannin. Now what happens, this tannin is negatively charged. Tannin contains negatively charged particles. See, animal hide is positively charged, tannin is negatively charged. It undergoes mutual coagulation. And this process is called as tanning. Alright, so next is in rubber industry. In rubber industry, you know, the manufacturing of rubber, the colloidal solution that is used is latex. Latex is the colloidal solution. So this will be treated with particular solvents or say acids with which the coagulation can be brought out and the rubber can be used. So again, it's very important. The other one, in the photographic films or plates. Photographic films or plates it is used. There what happens is the colloidal solution will be usually coated for the photographic plates with which it can be used. And the other one is industrial application. There are n number of industrial applications of these particular colloids. Example, paints, cement or whatever you see, most of them are colloidal in nature. So these were a few importance of colloids in day-to-day life or which we commonly see. So in the next video, we will meet with a new unit, that is general principles and processes of isolation of elements. Thank you.